The cover of the book shown here is authored by astronomy and geology experts. It attracted my interest because it emphasized that the likelihood of advanced multicellular life in the universe is very small. They proposed that the moon was an important but not essential ingredient for life to form, and that single-celled life is relatively common in the universe. As a physician and chemist, I have more respect for the incredible complexity of a single living cell, so I have researched across all the scientific disciplines to give you what I think is a better perspective concerning the critical effect our moon has had for life to develop. Each of the following slides could be extended into a full lecture, so for brevity, I leave you to accept the basic information presented on faith or do your own research, which I recommend. In fact, the full story will still be too long for a comfortable single setting, so for your benefit I will divide it into two parts. In part one, I will show you how the Earth acquired just the right conditions for the so-called original organic soup to develop all of these features which define the presence of life. That is, they must reproduce, use energy, they are made of cells, they must change over time to adapt, they must grow and develop, they must maintain homeostasis, they must respond to their environment, and they must be based on a universal genetic code. I will show you the many critical effects our moon had on Earth. These include volcanism, the magnetosphere, axial tilt and spin, and plate tectonics and tides. In the second part, I will show you how these factors created the exact conditions critical for the transformation of that organic soup into living cells. Popular media generally follows the reasoning of one branch of science at a time, missing the big picture. The moon appears to be an incidental character in life's origins until all the science inputs are assembled together. I am going to merge the input from all these branches of science to show that without the accidental acquisition of our large moon, the right conditions for life to form could not have happened. My most important message for you related to this is that the ability of complex life to adapt to different environments, such as hydrothermal vents or the Arctic ice over millions of years, has nothing to do with the conditions necessary for life to begin. We'll start out by showing you how we acquired our moon. This is an example of the way early chaos in our solar system dramatically changed the orbits and inclinations of the original planets and other bodies. Jupiter and Saturn got into an orbital resonance which forced Neptune out of its original orbit into the outer solar system. Incidentally, also kicking 99% of the icy Kuiper belt objects into the inner planets, helping Earth to get its water. In addition, an Earth-sized object was pushed into a collision with Uranus, pushing it on its side. The asteroid belt between Earth and Mars is a particularly chaotic area because of the effect of Jupiter's gravity. Computer simulations suggest that a Mars-sized object originated there and was pushed into a collision course with the proto-Earth to form our moon. In the next slides, I will show you how this unlikely event changed our planet from a completely inhospitable place for life to form into the Eden we are lucky to share. This is the story of Goldilocks Earth. This slide and the next one will show you exactly what happened when this body that we call Theia struck the Earth. Both bodies were mostly liquid when they collided, with a thin crust floating on liquid mantle. Fortuitously, the impacting body was just the right size and angle to add spin and a just right axial tilt. Much of our crustal material was thrown into orbit and formed the surface of the Moon. This left large gaps in our crust, which were eventually filled with water. Unlike other inner planets, this created deep gouges to hold our oceans, allowing critical tectonic movements to develop. The next slides will show why this is important for life to exist. After the collision, the lighter orbiting debris formed the Moon, which has only 1.2% of the Earth's mass. This happened in only a few hundred years, and much of the otherwise unavailable heavy elements from the original body fell back onto Earth's surface, where life can still access them to flourish. Note, all large bodies differentiate by moving all the heavy elements into the core before they solidify. All living cells, on the other hand, depend on protein catalysts, which incorporate about 20 separate heavy elements to perform critical functions. In the next slides, we will show how the effects of our unique large Moon made these materials available in the oceans and over the entire land surface of Earth. Here is a summary of the next topics I will cover in part 1 of this presentation. Namely, the initial too small core was fortified by Theia's core. It enhanced the magnetosphere, allowing extended persistence of liquid dynamics. Volcanism and plate tectonics are critical to maintain land mass, avoid runaway greenhouse, unlike Venus, and allow recovery from extended ice ages. The just right axial tilt allows solar heat distribution on land and sea. Massive tides caused by the early nearby Moon brought fresh nutrients onto land and broke up crustal material, creating soil and clay on which life was able to form. Our life-protecting magnetosphere is unique among the 4 inner planets. Even though Venus has a similar liquid core, it lacks the necessary rotational velocity to create a dynamo-driven magnetic field. This diverts the Sun's harmful particles, which would otherwise destroy life's organic compounds and cause the loss of our water, as happened on Mars and Venus. In addition to tilting the axis to 23.5 degrees and importing a rapid rotation, initially with an 8-hour day, Theia donated critical mass to Earth's core, as you will see in the next slides. Perovskites are the latest fad in electronics, but are also the main component, 98% of Earth's mantle. It is normally a good insulator, which is why our core has remained molten. By another Goldilocks coincidence, there is just enough mass in the Earth to crush the innermost atoms of the mantle material into a special arrangement called post-perovskite. This thin layer allows much better transfer of heat from the outer core to create liquid plumes of magma which rise to the surface. Without this assist, Earth would have had little or no volcanism. And, on the other hand, if there was a lot more mass, volcanism would have been much more extensive, and the core would have solidified with loss of our magnetic sphere. Another Goldilocks coincidence. Here is a computer simulation of the effect of post-perovskite on volcanic activity. I will give you a minute to read about it. Then in the next slide I will discuss just what volcanism has meant for the formation and maintenance of life on Earth. First of all, volcanism and plate tectonics are both critical for the process of land renewal. Without this renewal, the land would be eroded away and Earth would have become a water world. Second, the volcanic ash is very rich in the nutrients needed for life, and the output is easily broken down by wave action into soil and clay, which you will see later is another critical ingredient in the formation of life. Third, episodes of hypervolcanism changed Earth's atmosphere to save us from permanent glaciation, which we call snowball Earth, on at least 2 occasions. So our Goldilocks climate is delicately balanced by complex feedback loops, which maintain CO2 levels at just the right level, and before Industrial Revolution, CO2 was maintained by volcanism versus removal by precipitation as carbonates, and movement by plate tectonics into the subsurface. This removal was enhanced when the supercontinent Pangaea broke up, causing significantly colder average temperatures and a runaway Earth-wide freeze, as the progressive glaciation reflected more of sun's energy. Fortunately, volcanic activity stimulated by further plate movement saved the day after several 100 million years. Our Goldilocks climate is delicately balanced by complex feedback loops, which maintain CO2 levels at just the right level. Before the Industrial Revolution, CO2 was maintained by volcanism versus removal by precipitation as carbonates. This removal was enhanced when the supercontinent we call Pangaea broke up, causing significantly colder average temperatures and a runaway Earth-wide freeze, as the progressive glaciation reflected more of sun's energy. Volcanic activity eventually occurred, stimulated by further plate movement, and saved the day after several 100 million years. This slide is a summary of plate tectonics. Rising plumes force the ocean floor to push laterally. The upper crust, which you remember was left after Theia struck, has room to move away, and the deep ocean between the pieces of upper crust acts as a lubricant to allow the moving ocean floor to pass under the crust, causing land to lift up and stimulating local volcanism along the edge. This volcanic cavity and crust lifting replaces the land that is gradually eroded by weather activity. Next, we can consider the significance of the Goldilocks axial tilt and spin we acquired when Theia struck. It happens to be just right to bring the alternate heating and cooling conditions to the temperate zone for the most important chemicals for life to form. The chemical reactions to form the ribose backbone of RNA cannot happen in a purely aquatic acellular environment, such as deep-sea vents. It is important to remember that life, once formed, has an immense ability to adapt to harsh environments, but this is totally unrelated to the requirements for the first life to form. As noted on this slide, Coriolis forces caused by the spin and axial tilt greatly enlarge the habitable zone by mixing hot and cold air and water and pushing tropical storms over land. Finally, let us consider how important the lunar tides have been to the story of life. When water could condense onto the new Earth, the moon was 10 times closer than it is now, and the days were 8 hours long. The tides were 600 feet high, and there was an eclipse every day. These violent tides striking the crust along with continuous meteor bombardment were critical to breaking down the crustal material to make soil and clay. More on the clay story in part 2 of this presentation. The tides also helped to bring volatile organics and CO2 into the oceans. 600-foot tides carried critical dissolved elements across the entire land surface. This is why living organisms can find the necessary ingredients to grow anywhere on the earth today. This tide summarizes the previous points. Without tidal action, the oceans would have been stagnant, with little or no soil, and clay would have been formed. CO2 would have remained in the atmosphere, leading to runaway greenhouse effects. Nutrients in the rocky surface would not have been efficiently dissolved to become available to living cells. Fatty acids floating on the surface have to be agitated by wave action to become suspended as tiny cells to enclose new RNA and protein strands in the first steps toward life. We'll discuss that more in part 2. This is the end of part 1 of my presentation. In part 2, I will show you that even the minimal structures needed for a living cell are much too complex for life to develop on a pure water world. Then I will discuss the latest best guesses as to how the first cells developed, and then after a review of all the things our moon has done for us, I will touch on the likelihood of any life developing on Mars and Jupiter's moon, Europa.